Hi, this is a 6-part tutorial series to teach you how to make your first platformer in GameMaker. The purpose of this tutorial is to help you learn what you can do with relatively simple code so that you can start making your own games in GameMaker. And in this tutorial, you're going to learn about momentum-based movement, jumping, wall jumping, save and load systems, checkpoints, enemies, a weapon system, everything you need to know in order to build a relatively simple game pretty quickly. In this video, we're going to cover moving, jumping, collisions, and animations. And before we get started on this series, a couple of notes. First, I encourage you to use a 3-button mouse. A 3-button mouse is a mouse with right and left buttons that are separate from each other, and then a scroll wheel that clicks up and down and scrolls up and down, and also you can click with it. You can press down and click with the scroll wheel, because that will be part of some of the shortcuts that we're going to be using, and it's just good practice when working in GameMaker to have a good 3-button mouse. This one costs about $30 and it has a much higher DPI, so it's much more sensitive. I like it, but you can literally go online and buy a $10 3-button mouse and plug it even into your Mac computer or your Windows computer, and also don't use a Mac mouse. Those are horrible for working in games. Another tip before we get started is to use a large monitor if you can, because GameMaker works best when you're using a large monitor instead of a really small monitor. All right, let's get started. Whoop. You saw my notes there? Let me move my notes over. There we go. So when you open GameMaker, this is what you should see. And we're going to get started on the project. Quick note, if you haven't watched my previous tutorial where I introduce what GameMaker is, I would encourage you to watch that and follow that before you get into this tutorial, because in this tutorial I will be going a little faster and I won't be explaining every function that I use. Instead, when I use a function, I might explain it a little bit, but to learn more about it, I encourage you to look in the help manual and look up those functions yourself in GameMaker. And again, a handy shortcut, you can click on any function or any highlighted word in GameMaker code with your scroll wheel, and it will open the help manual for you and you can read about it. So get in the habit of doing that so you can learn how these functions work. And we will get started. We're going to click new game, and I'm going to call this first platformer tutorial dash 2023, but call it whatever you'd like. And I'm going to click let's go. Here's our workspace, and we're going to get started. First, make sure under target build it doesn't say gx.games, because gx.games is a horrible web browser for playing games. Instead, you're going to click test Windows or Mac. Most likely it will say test on your version. Mine says Windows, but test Windows or Mac. Click that, so that will be your target build for the game. Go to sprites, create a new sprite. I'm going to call mine S player, lowercase s, of course, that's my naming system. And I'm going to import the images I have for this player sprite. Now, to find the asset library, or not the asset library, to find all of the images and the sounds that I use for this game, I've made them myself so that they're free to use. You should be able to find it either in a description of this video, or if you're watching it on someplace besides YouTube, you should be able to find a link to that Google folder somewhere else. But I will post it so you can download all of the art assets and sound assets for the game. So I'm going to click import, and I'm going to find it where it is on my computer. There we go. And I'm going to find the S player sprites, the ones that are just called S player 0 through 6. So there's 7 total, 0 through 6. I'm going to highlight all of them and click open. And there we go. Set the frames per second to 10 and the origin to middle center. And now I can click a preview to see a little breathing animation for our player sprite, who's just going to be standing there. Now I'm going to create a new object and call it O player and set the appropriate sprite. And I will rename our default room, the first room GameMaker gives us. I'm going to hit F2, or you can rename it a different way. And I'm going to call it R level 1. And I'm going to open that and change the width and height to 960 pixels by 704 pixels, 704 pixels. And I will make sure the instances layer is highlighted, and I will drag the OPlayer object into the middle of it. Now we're going to start coding our player object. oPlayer, step event, GML code, don't ask again for this project, okay. Comment get inputs, key right equals keyboard check VK left, key left, sorry, I already made a mistake. Key left equals keyboard check VK left, key right equals keyboard check VK right. There we go. So this is going to give us variables to let us know when these buttons are being pressed. Now we'll write a new comment, get move direction, -1 is left, 1 is right, 0 is nothing. And the code var for a local variable, dir, meaning direction, but we're going to write dir, equals key right minus key left. So this will make it so that when key right and key left are both pressed at the same time, it's going to result in a 0, but when key right is pressed, it'll be 1, so it means right. If key left is pressed, it'll return -1, which means left for this dir object. Now write new comment, get horizontal speed, negative HSP means left, positive means right. HSP, which stands for horizontal speed, but we're going to call it HSP, plus equals dir times XL, a variable called XL. So this is going to take the direction, -1, 0, or 1, and it's going to multiply it by how fast we want our horizontal speed to increase. Lastly, let's commit the horizontal speed to the object's X position, so X plus equals HSP. Now we need to declare these variables that we've created or added here to the step event. So we're going to go to our create event and write comment speeds, and then write HSP equals 0. Comment a horizontal speed variable, not called hspeed, because hspeed is a named thing in GameMaker that we can't use. Then new comment player inputs, key left equals 0, key right equals 0, comment momentum, XL equals 0.5, and I'm going to comment an acceleration variable set to 0.5. Now let's test it out. Run the game. When I hold the left arrow key and the right arrow key, starts speeding up. Now you notice the character does not slow down. It just increases the speed, but we have a momentum-based system now. But we will make it so the character slows down when we're not pressing buttons. All right, to do that, we need to write this code in the step event before we commit to the horizontal movement. So right here, I'm going to write if dir equals 0, meaning like either both keys are pressed or no keys are pressed. And remember, double equal sign when we're checking a value. Yeah, let's do our bracket system like that. So there's two, my last tutorial series, we did our brackets like this. We hit return before our curly brackets. In this tutorial, I'm going to do what a lot of other people do, which is start your first curly bracket in the same line as your condition statement. If you've never done that before, it might take some getting used to, but honestly, it saves some lines and I think it looks better. If dir equals 0, which means comment slow down character if no direction key is pressed, I am going to write indent here. If HSP is less than 0, open curly bracket, close curly bracket. I'll write another comment going left. HSP equals min, the function min, HSP plus decel, which is a new variable we're going to declare, comma, 0, close parentheses, semicolon. So min is a function meaning minimum in GameMaker, which looks at a set of values and it returns the lowest value. So HSP plus, whichever is lower, HSP plus decel it will assign to HSP, or 0, whichever is the smaller one, if it's going left. Else, indent, make sure everything's properly indented so that you can keep track of your code. Else, open curly, there we go. At the end here, else, open curly bracket, close curly bracket, indent. And this means comment going right. So if HSP is negative, it means we're going left. It is positive, it means we're going right. So this means we're just checking when it's positive. HSP equals max. HSP minus decel, comma, 0, close parentheses, semicolon. So this is maximum, and it returns the bigger number, either HSP minus decel or 0, and that's a way of slowing down. Now to set a max speed, meaning we want some values to set like the maximum speed that we can go. We're right before we commit to horizontal movement, we will write HSP equals clamp, which clamps the value so it doesn't go beyond a certain range. The first value we're going to write is just, or HSP, this is the value that we want to clamp, comma, and then the two values or the range that we're going to set this value to is negative max HSP and max HSP, which is a variable we're going to declare. Set the max speed, comma, left or right. Now we got to declare these new variables in the create event. So under speeds, I'm going to write max HSP equals, let's say 5, semicolon, a max horizontal speed. And then under momentum, I am going to write decel equals 0.3, semicolon. A deceleration variable set to 0.3. Now run the game and see if it works. There we go. So when I hold down a key, it does take a few frames for the character to reach the max speed. And then when I let go, it takes a few frames for the character to slow down to 0. So we have a momentum-based system now. And you can play around with these values, the max speed, the max horizontal speed, 5, you can adjust that, see what feels right. Acceleration and deceleration, you can play around with these values and see what feels good for you. I just set them to what I think feels good. I might even change them later in the tutorial, but you can go ahead and play with them now and see what feels good to you. So now let's add some blocks to contain our character, some collisions, let's add some gravity and a jumping mechanic to our platformer. So I'm going to close out of this and we are going to create a sprite and I'm going to call it S block. And for S block, just make it a solid color. We're going to keep it the same size of 64 by 64. Let's click edit image, fill tool. Let's just set it to, I don't know, bright fuchsia. Set the origin. Let's keep the origin to top left, I think. Yeah, I think that's right. Yeah, the origin we want to keep for top left for how we're going to place it in our room. Close out of that, create an object, call it O block, assign the appropriate sprite. Close out of that, go to our level 1, and under instances, let's make sure our grid is set to 32 by 32, which it is, which is half the size of our block. Actually, no, let's set it to 64 by 64. It'll make it even easier because our origin is top left corner. It will paint within the grid here, which is going to look really nice. So we're going to zoom out. I'm going to hold the control or command key and use my scroll wheel to zoom in and out a little bit. So I'm going to zoom out a bit, make sure the instances layer is selected, click block, and then hold down the Alt or Option key. And by the way, these won't work if you're on a laptop. There's a little toggle up here that says laptop mode. Turn that off. And then more of these shortcuts will work. So if you turn that off, and then when you hold the Alt or Option key with an object selected, you can use it to paint with objects. So what I'm going to do is I'm going to paint a border around our room to keep our character within the room. And yeah, let's make the floor varying heights. also, so when we get to jumping, we can test our jumping. Close out of that. Let's open our OPlayer up again because now we're going to add a collision system. So before we commit, here we go, step event. Before we commit to our horizontal movement, we want to check to make sure we can actually move to where we're moving to. So we're going to add the collision system right before this. So right before x plus HSP, I'm going to write a comment, horizontal collision, if I know how to spell. And then write our collision system, which you can use in a lot of different games, a lot of different purposes. A lot of different people online even use this exact same collision system. I learned it from somebody else. Right? If place underscore meeting, open parentheses, x plus HSP, comma, y, comma, O block, close parentheses, open curly bracket, close curly bracket, var 1 pixel equals sign HSP, while bang, or exclamation point, but we call it bang, place meetings. So when we're not overlapping with the following object, x plus 1 pixel, comma, y, comma, O block, close parentheses, space, and we're going to make this an inline statement, so no open or close curly brackets. Just right after those double close parentheses, we will write x plus equals 1 pixel, semicolon, and then return and write HSP equals 0. And then right here, we're going to add another comment and write commit to horizontal movement. If you don't understand how this collision system works, you can watch my first tutorial in GameMaker where I explain it more expansively. But basically, what this checks to see if with our HSP, if we're it checks the distance. Hey, in the distance that we're about to place our player object, are we going to overlap with a block object? If so, hold the phone, stop everything. We've got to do some calculations. First, find out if we're going left or right and assign this variable -1 or 1 based on which direction we're going. So it's just 1 pixel, either -1 or +1. And then a while statement that says, hey, for the, are we in 1 pixel, are we overlapping the block? No, move a pixel. In the next pixel, are we overlapping a block? No, move a pixel. And with a while statement, it all happens in a single frame. So you don't see it actually moving 1 pixel by 1 pixel. It just happens all at once. And then after we reach the block, we change our HSP to 0, so we stop moving. And then after all of that, our HSP should be appropriately calculated, so then we can commit the X position of the player object to its horizontal speed here. So let's run the game and see what happens. So we're still floating because we haven't added gravity. Oops. So when I hit left and I hit a wall, it stops. Over here, hit a wall, it stops. Now, because we're dealing with collisions, we're going to do something really quick. We're going to open our player sprite and open collision mask and make sure that the collision mask is appropriately set. So it goes all the way to the bottom of the sprite and over here to where the arms are. Everything is set appropriately, so we don't need to change any of that. Now, we're going to copy this entire section and then make it vertical. So where it says horizontal collision, I'm just going to copy that all the way to here where we commit the horizontal position. I'm going to hit Control C or Command C, and then I'll hit Command or Control V to paste it here, and I'm going to change this all to vertical. So vertical collision, place meeting X, comma, Y plus VSP, which is a variable we're going to declare later, 1 pixel sign VSP, while not place meeting Y plus 1 pixel, O block, Y plus equals 1 pixel, VSP equals 0, commit to vertical movement, Y plus equals VSP. And then in the create event, we need to declare the VSP variable. So VSP equals 0 for vertical speed, vertical speed variable, not called VSpeed. So we won't notice really difference. We can run the game to make sure we haven't created any bugs, which we haven't, but we haven't added any gravity, so there's nothing telling GameMaker that our characters should be going up or down. So let's fix that. Back to the step event. We're going to add a comment where the code calculates the horizontal movement and comment it as, there we go. New comment here before everything, calculate horizontal movement. And then we're going to add a section right after that with a comment right before the collisions start happening. Calculate, need a comment, calculate vertical movement. And in that section, I will write VSP plus equals grav for gravity, but don't call it gravity, call it grav. And then we will declare gravity under speeds, or grav equals 0.5. And so this should at least give our VSP something, so we should fall down. Yep, we fell down. Let's add a quick restart command so that we can more quickly test things, which is a common thing when you're prototyping a game. At the very bottom of our player event, we're going to write a new comment, quick restart game if keyboard check pressed, VK enter, close parentheses, open curly bracket, close curly bracket, game underscore restart, open and close parentheses, semicolon. So now when we hit enter, it should quickly restart the game. And you can see we're falling. Beautiful. Now we're going to add jumping to our game. In our get inputs section of our code, we will write key jump equals keyboard check pressed, meaning we actually have to, it checks for the single frame that the button is pressed, it does not check whether we're holding it or not. VK up, and then key jump held equals keyboard check, VK up. So we need these two keys because we're going to add a variable jump, meaning that when you press the jump key, we're going to make it so you're not just going up a single distance, that if you press and hold it just a little bit, you'll jump a little bit. Press and hold a lot, you'll jump higher, which is much more common in platformer games. And we'll go to the create event and declare those variables under player inputs. Key jump equals 0, key jump held equals 0. So to make sure we can only jump when we're actually touching the floor, we need to add some code to the calculate vertical movement section underneath where we set the gravity. New comment, ground jump. If jump buffer is greater than 0, open curly bracket, close curly bracket, and a comment here. Check if the jump buffer is greater than 0. And then within those curly brackets, indent, jump buffer minus minus, semicolon, which subtracts 1 from this value every frame of the game as long as it is above 0. New comment, reduces jump buffer variable by 1 each step. And remember from my first tutorial series, there's different ways to write this, but this is just the fastest way to write the same thing. But if you don't know what that means, go watch my first tutorial series. Then return. If key jump, open curly bracket, close curly bracket, and again, another comment, check if jump key was pressed, then go in those curly brackets, indent, jump buffer equals 0, comment set jump buffer to 0, meaning can't jump again, and then VSP equals jump speed, semicolon, comment jump up. And then at the end of the step event, add a section called calculate current status. And we'll declare these variables in a moment, so we don't need to worry about it. let's see, right before the restart game, I'll add a comment called calculate current status. On ground equals place meeting x y plus ground buffer, comma, O block. And if on ground is true, jump buffer equals 10. So this lets us know that we're on the ground or not, and also gives us what we call a jump buffer, which is a way of letting the player jump a few frames after they've left the ground. It just feels better, especially if you're going off a cliff and you think that you've jumped right at the edge of the cliff. You have a few frames where you're not touching any ground where you can still jump. Some designers call that coyote time. And we also have added a ground buffer. So instead of just adding y plus 1, which we could have done, which would have checked if we're actually touching the ground, this gives us some flexibility when jumping around. So if players are just close enough to the ground, they can still jump, even if they're like a few pixels away. And again, it just feels more natural. It just feels better. Now we need to declare some variables in the create event. Let's go to the create event and add a little section called jumping with a comment. And then write on ground equals false. Ground buffer equals 3, semicolon. Lets us jump if we're at least 3 pixels close. And then jump speed equals -12, semicolon. Jump height more negative equals higher. Jump buffer equals 10. Frames after leaving ground when we can still jump. So note that this jump speed here cannot be bigger than max VSP, which we are going to set to 12 in our game, but we haven't done that yet. We're going to do that later. So when we get to there, you'll see that I'll set our max VSP to 12, but if you want a higher jump, you need to change the max vertical speed, but we'll get to that in a moment. For now, let's just check to see if this works. Can I jump? Yeah, so right now we don't have a variable jump coded yet. We just have the basic jump. So if we press the up arrow key, we get a single jump height, but our jump is working. Now we need to make it so that when we only press the jump key a little bit, we jump a little bit, and when we press and hold, it jumps higher, which is called variable jump. Let's go to the step event to the ground jump section. Here we are. And we're going to add this line, which gives us variable jumps. And I can write it after, I believe, here. If VSP is less than 0 and double ampersand signs, bang key jump held, meaning if key jump held is 0, essentially, if we're not holding if we're not holding down the up arrow. Open curly bracket, close curly bracket. If going up and not holding jump key, indent VSP equals max VSP, comma, -3. Close parentheses, semicolon, set VSP to higher, less negative number. Now let's add a cap to how fast we can fall and rise, just like we did with the horizontal movement. After that, VSP equals clamp, VSP minus max VSP, comma, max VSP, close parentheses, semicolon. Now we just got to declare max VSP in our create event. And again, with max VSP, I'm going to set it to 12 here, semicolon, maximum vertical speed. This number, or more like, it's more like this number, this 12 here, cannot be a bigger number than this number, because if we try to set this to jump speed -16, for instance, our max VSP is always going to be capped to either 12 or -12, no matter what. So if you want to make your jumps higher, be sure to also increase max VSP to whatever that value is. Set that back down to 12. Now, if we run the game, we should now have variable jumps. So if I just hold down, if I just press the jump key just a little bit, we jump a little bit. When I hold, we go higher. And also we can test our ground buffer and our jump buffer. So right now, if I fall off this little edge here, and if I hit the jump key right after falling, I can still jump. Now, right now it's really pronounced, and I can reduce that ground buffer variable if I want to make it more subtle. Right now I made it really extreme just so you could see it. But if we wanted to, we could change ground buffer from 3 to like 2 or 1 to make it more nuanced. And also made it so you don't have to be exactly on the ground to jump. We can be a few pixels away. And oh yeah, jump buffer. There we go. Jump buffer is for falling off the cliff. So jump buffer, that's our coyote time. So right now it's set to 10 frames. If I set it to like 4 frames, it'll be a little less pronounced when I'm falling off a cliff here. I can still jump after the cliff, but if I am too late, I can't jump. So yeah, I think 4 is a better number anyway. And then ground buffer, we can increase that to like, I don't know, 15, just to make it ridiculous. So we can jump even if we're fixed 15 pixels above the ground. Come on, let's see if I can time it right. So I want the ground buffer to be like 10. There we go. I just switched these values around. Ground buffer I'm going to change to 10, and jump buffer I'm going to change to 4. Now let's create some animations. First we need to import some sprite images. We're going to create a new sprite and call it sPlayerRun. And we're going to import the appropriate sprite. So here we have sPlayerAir, sPlayerRun0 through sPlayerRun 11. So there's 12 images total, 0 through 11. Open that up and set the animation speed to 30 and set the sprite origin to middle center. And you can hit the animation key to see the speed. If that's too fast for you, you can change the frames per second to something lower. I think it looks good. Close that. And for another new sprite, create sprite, call this sPlayerAir for when our player is in the air. And there should be 2 sprites, sPlayerAir0 and sPlayerAir1. Open both of them. Set the frames per second to 0. Set the sprite origin to middle center. So this is important. The next part is really important. We need uniform collision masks for all of our different player sprites or character animation sprites, but GameMaker makes it super easy. All you have to do is go to our oPlayer object, and it's going to say collision mask. And right now it's set to same as sprite. Instead, we're going to change it. Instead of same as sprite, we're going to just change it to always be the same collision mask as sPlayer, because we're going to be changing our sprite with code to the running sprite or the jumping sprite or just the standing still and breathing sprite, but we always want the collision mask to be the exact same, which is sPlayer. Now we need to tell the game to use these different sprites. Create a new section at the end of the step event somewhere. Let's put it right after our calculate current status, because that's going to be important for telling us the animation that we use, but we want it right before our quick restart game. I misspelled that. I'm going to write adjust sprite image speed equals 1, semicolon, 100% of animation speed. I'm going to indent and add a comment and write if moving, comma, orient sprite according to direction of movement. Then back here, get flush left. If HSP does not equal 0, image x scale equals sine HSP. So x scale can warp a sprite horizontally. And if you set it to 1, it just means orient it normally. If you set it to 0.5, it means squash it by 50%. However, if you just set it to -1, it flips it horizontally entirely. So here it will always flip our sprite image appropriately left or right, depending on where we're moving. Now, for our running animation, that matters a lot because right now the animation moves right, but if we're moving left, we want the run animation to move left. So that's why we do that. And then another if condition, if not on ground, open curly bracket, close curly bracket, add a comment, if in the air. And then right index equals s player air, semicolon, image speed equals 0, stop animation speed, make still image, image index equals ESP greater than 0, close parentheses, semicolon, falling equals 1, everything else equals 0. So this, because we put this in parentheses, it'll check if VSP is greater than 0, and if VSP is greater than 0, it's going to return this as true or just 1. So if it's 1, it'll change the image index to 1, and everything else will return a 0 for image index, which is important because our image index has 2 sprites, and the first sprite is the 0 image, and the next image is 1. If you remember from my first tutorial, in these 2 images, this one right here is image 0. This one is image 1. If you added another one, it'd be image 2, image 3, image 4, but it starts counting at 0. And for this reason, we have this kind of, I think, pretty elegant code to say, hey, if we're falling, make it image 1. For everything else, make it image 0. Then here, write else, open curly bracket, close curly bracket. Then another comment, if on the ground, indent, if HSP does not equal 0, close parentheses, open curly bracket, close curly bracket, add a comment, if moving left or right, indent, sprite index equals s player run, semicolon. Then over here, write else, open curly bracket, close curly bracket, add a comment here, standing still, indent, sprite index equals s player, semicolon. So this is all of our different sprites, s player run, s player air, and it just goes one by one to check which state we're in, and according to the appropriate state, it sets our appropriate X scale or horizontal scale to be oriented left or right, also the appropriate animation speed, and also sets the correct sprite. So now we can test it out, and we should be able to see our 3 different sprites. So I'm running left, it's oriented left. When we're running right, it's oriented right. When I'm jumping, we have an up image and a down image, those 2 different images. And then when we're not moving, it just stands still and it breathes. And we have a little animated character now with even variable jump. All right, that's it for our first video. We have a moving character, we're jumping, we have a collision and gravity system, we have our animation set up. This is the first basic step to get the mechanics for our game going. In the next video, we're going to learn about wall jumping, how to make a wall jumping mechanic. We're going to have an enemy system, a checkpoint system, and even a little combat system, which will be fun. So I will see you there.